Today we're going to start taking a look at 14.4, which talks about the normal distribution, and we are going to spend a couple days looking at this. So these first slides, differ slightly from what you have here. We're not going to be measuring tennis balls today, but they are some examples of what a normal distribution here. If you make a histogram of various things, such as this first one, I think this is the height of men, possibly in inches, I think. You'll see it follows this bell-shaped curve with our average in the middle, and then on either side the heights of men getting smaller and the frequency of those men getting smaller. IQ scores also follow this as well, and I think on the next slide I have one more here. This is the heights of men and women. So you can see it's not a perfect all the time curve here, but it models what we call the normal distribution. So this is an example of the bell curve here. So in this middle, this highest part is usually our average, with the most people being, if we were to do heights, this height of that average, and then it falls off on either side. So a couple properties about this normal curve or the bell curve. It's symmetric, the mean is in the middle, and the standard deviation determines the shape of the curve. It's the distance from the mean to the change of curvature points on either side. And then there's some data right here. 68.3 of all data is within 1 standard deviation of the mean. 95.5% of all is within 2, and 99.7 within 3. So if we take a look at this next one here, what we can do is we can see what they were saying by that data. So you'll see 1 standard deviation is right here on either side. So 68.3 lies within 1 standard deviation. Our second one, well, they have it right here, I guess it is 95.5 and 99.7. So if we were to take a look at this curve, 1 standard deviation, we're going to take a look at that. Here's our curve. That's horrible, but our mean is in the center, and then where that curvature changes, maybe right here, this is 1 standard deviation. So as it said on the previous screen, 68.3% is within here. So that would mean that 34.15 and 34.15 is on either side. The total standard deviation below and above is 64.3. Now, if we were, probably should have looked at this first, if here is our mean, how much of our data lies on this would be 50% over here and 50% on the other side. If we were to take a look at the 2 standard deviations, again, you will get pretty good at drawing these by the end, much better than I am here. Here's our mean. Here's the 1 and the 1. And if here is 2 standard deviations, and here is 2 standard deviations, within these two, what did we say? We have 95.5. So to figure out on either half here, from here to here, what would we do with 95.5? Well, we would divide it by 2. So 47.5 and 47.5. And we could continue and do the same for the third one as well. Now, taking a look at this, this is how we're going to start applying this today. Jenna scored a 600 on her critical reading section of the SAT. How good of a score is this? And the SAT exams are scaled so that it follows a normal distribution with a mean of 500. So first thing, we're going to do lots of drawing here. Here's our mean of 500. Here's where that curvature changes, and we know our standard deviation is 100, so this would be 600, 400, and we could go out, the second one would be 300, 200, 700. So if you wanted to label this, this is 1 standard deviation, 1 standard deviation, 2 SDs, 2 standard deviations, 3 standard deviations. And she scored 100, so she scored right here. Now we need to figure out how well did she do? Well, pretty well, definitely above the mean. So if we think of this in terms of area, we know that this is 50% of the data is underneath here. Well, how much more is she above? Well, we can go back to that chart that said 68.3 is within 1. So again, we know the distance from here to here is 68.3. So half of that would be 34.15 in this area. So then 50 plus 34.15 would be 84.15. So she was in that 84th percentile. So 84% of the people did worse than her on the test. So that's not too bad. We talk about these standard deviations where 1, 2, 3. This is also sometimes referred to as the z-score. And the way you find the z-score, that's how many standard deviations away you are. From the mean. And it can be either above, or you can have a z-score that's negative below. And it's pretty easy the way you do this. You take your value. Well, she scored 600. In our case, 600, the mean was 500, and you divide it by 100. So 100 over 100 is 1. So she was 1 standard deviation above the mean. So we're going to calculate out a few of these here. The ACT is taken. You guys have all taken that. The test scores are normally distributed. So that means it follows that curve. The mean is 20.8 and the standard deviation is 4.8. So let's see, minus 4.8 and plus 4.8. See if you guys can calculate those out there. Give you a minute. So hopefully you got 25.6 and 16. So when you think about this, I mean, if you want to know where you fall on your test, 68.3% of people scored in between here. All right, so let's see what we need to do here. The test scores of 4 students, find the z-scores. I think we're only going to do the 3. So to calculate out our z-scores, we take our score minus the average divided by our standard deviation. So 18 minus 20.8 divided by 4.8. So negative 0.583. So that means she wasn't even 1 standard deviation below. She's somewhere right in the middle of that. So our next one, 32 minus 20.8 divided by 4.8. And you should look at this and say, well, this one's definitely going to be positive. 2.33. So she did pretty well. She's quite a few standard deviations. She's above this next one, not quite to the third. And the last one, 14 minus 20.8 divided by 4.8. So she's below, negative 1.42 below the mean standard deviations. 4.8 standard deviations below the mean. All right, so the next one, last example we're going to look at. Let's see if we can find that here. This next one, and I think you guys have some room because we're going to be drawing some pictures here as well, but hopefully you have some room on your paper for each one of these. A truck is loaded with a carton of eggs that weigh an average of 2 pounds each with a standard deviation of 0.1. A histogram of these weights looks very much like a normal distribution. What percent of cartons is less than 2.1? So the first thing, we're going to draw a picture. So here's our curve. We know the mean is 2. And our standard deviation was 1. It's probably a little off from where it would be, but 1.9. So we could go out our 3 standard deviations, 2.2, 2.3, 1.8. And we want to know what percent of cartons weigh less than 2.1 pounds. So I'm going to highlight. We want to know how much is less than all this. Well, we know this area is 50%, so we have to find this little area here to add it. Well, we know 1 standard deviation, that total is 68.3, so we'd have 34.15 and 34.15. Well, perfect, we know this whole thing is 50, so 50 plus 34.15 is 84.15%. Okay? So let's see what the next one is asking us. What percent of cartons weighs less than 1.8 pounds? So I'm going to draw a new picture here. 2, 1.9, 1.8. So we want this business down here. How much is less than that? Well, 2.1, 2.2. Well, let's start counting. That's 1, 2 standard deviations. So we know this entire 2 standard deviations, what was it? 99.7. So 2 equals 99.7. So on either side, let's see, 99.7 divided by 2, what does that give us? 49.85. So if we were to divide this, we know that this is 49.85 and this is 49.85. So we have to think, how can we get this little chunk? Well, what do we know? The entire bottom half is 50%. So we can do 50 minus 49.85. Did I choose the wrong number here? I think I may have. Let's take a look. Uh-oh. Whoops. 2 standard deviations is 95.5. We have to change that slightly. I thought that was a little off. So 2 is 95.5. So how does that change our drawing? We just have to do a little change. Let's see, 95.5 divided by 2, 47.75. Because 2 standard deviations is that. So that changes, make this eraser small, these numbers here. Sorry about that. So we have 47.75 and 47.75. This looks a little bit better. So we have 50, the entire half, minus 47.75. So we have 2.25%. And the last one, oh, we can't even see it there. What percent of cartons weighs more than 1.9? Okay. Well, we know that this is 2, 1.9, 2.1, and we have this right here. So we know that this is 1 standard deviation away. So it's 1 standard deviation, which is 68, make sure we get this number right, 0.3% of the data. So if we divide that by 2, we have our 34.15. So we know 34.15 is here, 34.15. And we want to find how much is more than that. So we want this entire area. Well, we know the top half is 50 plus 34.15, and we get 84.15%.